Hi everyone! In today's lesson we are looking at Chapter 7, Section 2, Reflections. Our objectives are to identify reflections in a plane and to identify relationships between reflections and line of symmetry. Our standards are G code 2, 3, 4, 5, 6, 7, and 12. Here's our vocabulary words. First word is reflection. A reflection is a type of transformation that uses a line that acts like a mirror with an image reflected in the line. Line of reflection. In a reflection, the mirror line is called the line of reflection. Line of symmetry. A line of symmetry is a line that a figure in the plane has if the figure can be mapped onto itself by a reflection in the line. So if you can look at this picture, you'll see that in this picture over here, we have no line of symmetry if we cut the rectangle diagonally, because you can see that when we cut the rectangle diagonally, it does not fold onto itself. So there's no line of symmetry diagonally. However, if we cut the rectangle in half vertically, we can fold the rectangle over the line of symmetry evenly and onto itself, and so we have at least one line of symmetry over here. Example 1, reflections in a coordinate plane. Graph the given reflection A, J38 in the y-axis. So what we need to do is reflect the point 38 across the y-axis. So let's first plot 3 and 8. There we are. And notice we are from this point 1, 2, 3 points away from the y-axis. So if I were to reflect it across the y-axis, I'm going to go 3 points across the y-axis. So 1, 2, 3, and my new point is located at -3 and 8. Because J is 3 units to the right of the y-axis, its reflection J prime is 3 units to the left of the y-axis. B, K is at 7, 4 in the line x equals 7. So what we really need to do is reflect the point 7, 4 across the x equals 7 line of reflection. So first graph and label K and the line x equals 7. So here's x equals 7 and here's K at 7 and 4. Now, since we are reflecting across the line x equals 7, which is exactly where the x coordinate of this point, it just basically implies K is on K prime. So there's really not much reflection to do over here. All right, checkpoint problem number 1, 2, 3, and 4 are yours. It says graph the given reflection in the coordinate plane, label each image. We've got 1, A is at 0 and 2 in the x-axis, so you're reflecting across the x-axis. 2, B is at 5 and 1, reflecting across the y-axis. 3, C is at -4 and 3 in the line x equals -3, so you're reflecting across the line x equals -3. And D, 4 and 0 across the line y equals 2. We know how to reflect our points across the x and y axis graphically. Here's how we would do it algebraically. If we are given the x and y coordinates and asked to reflect it across the x axis, all you would do is take your original x and y and just change the y to its negative. So what it looks like would be x and -y. Here's an example. So if our original points are 3 and 5, when we reflect it across the x-axis, our new point would be at 3 and -5. If we are reflecting the points x and y across the y-axis, again, we're going to keep it as x and y, but this time we're going to change the x to its opposite. We would have -x and y. So an example of that would be if you're taking 3 and 5 and reflecting it across the y-axis, then we would get -3, 5. Also remember that a reflection is an isometry, meaning it does not change its size. Example number 2, finding lines of symmetry. How many lines of symmetry does a figure have? Remember, when we're looking for lines of symmetry, we're looking to see if we can fold the image over the line of symmetry evenly so that all points line up. And some images may have 1, some images may have none, some images may have more. So you just have to play around with it. In our first one, we have an oval, and if you look at it, we can fold it in 2 different ways evenly over the line of symmetry. So this oval has 2 lines of symmetry. Pentagon has 5 lines of symmetry, so there's 5 ways that we could cut the pentagon in half and fold it over the line of symmetry so that all of its points match up. And finally, the octagon has 8 lines of symmetry, meaning you can cut the octagon in half 8 different ways and fold it over the line of symmetry so that all the points line up. Alright, checkpoint problems 5, 6, and 7 are yours. Determine the number of lines of symmetry that the figure has. Here is figure 5, 6, and 7. How many lines of symmetry does each figure have? Alright, that's it from me. I'll see you all later.